Yeah, okay. Yeah, yeah. Uh, YouTube, I think I muted it, right? So, okay, thank you. So, I think nobody has joined yet, right? Let us wait then. So, it's showing one waiting in YouTube. So, what? So, it's showing one waiting in the YouTube thing, but it's showing waiting. He has not joined. Okay, okay, okay. Okay, then welcome to the live session. This course series VLSI design. I am Chandan Karfa. So we'll discuss for 1 hour uh, about any questions you have. Feel free to ask questions, and whenever I get questions, I'll answer. Otherwise, there is no meaning of this live session, right? So I'm waiting for the questions to come. So exam date is on 1st November. We are around 3 weeks away from the exam. I don't see any question yet. Please feel free to ask any questions you have on the course content, any suggestion you have on the course content, or anything you want me to add into the course. I'll be happy to accommodate everything in a future edition. Any constructive suggestions are welcome, because at the end of the day, uh, if student likes it, that's most important. And if something to be considered for future edition, I'll be happy to accommodate, right? So, or if you have any doubt about any part of the course, please feel free to ask questions from the technical content, anything, right? So try to use this 1 hour effectively, so that uh, I'm yet to get any questions so far. Uh, Good evening. So any questions are welcome. Don't hesitate to ask any questions. So everything is fine. I hope you're enjoying the course, by the way. You're all, I think now the 11th week is going on, right? So almost end of the course, and everything is covered so far, right? So in 11 week means we are already going into this. Uh, we have already covered this. The most important part of the course were efficient synthesis of the C code, hardware efficient C coding, and all the optimization that high-level synthesis tool provides, like the pipelining, unrolling, and all those things, data flow, everything is covered, right? Now, FPGA technology mapping, then secure design with high-level synthesis, all those things are covered, right? So by this time, you should have a very good knowledge about high-level synthesis or CBS VLSI design. It's up to now, how do you use this, right? And probably you have noticed that this year I have introduced 2 demo session. I hope that is useful to you. In the demo, uh, we in the demo session, I have taken the VLSI tool and taken an example and show how to simulate it, C simulation, then high-level synthesis, and then also how to do the RTL simulation, how to understand the code, right? Uh, so all those things we have covered. I hope that particular demo session is quite useful. It was a request from last year students. So this year we have added that. So if you have any other student, I mean other questions or the suggestions, I'll be happy to accommodate this in the future edition, right? Uh, so there are 2 questions so far. I can see Devang asks, for the exam we have to go to the center or in home. You have to go to the center. Uh, it is not from home. And there is one more question from Rohit. Can the other background student also understand, sir? Yes, I think the students who is from electronics, electrical, and computer science, they will be able to understand this course quite well. And other branch like mechanical, civil, I think they don't need this course, honestly. People who are into this electronic circuit design, or they are they're planning to join the semiconductor industry, this course will be very much useful, right? Mhm. I think this is a very good question, but only the problem is the name is Bachpan Ka Memories. I don't know what is his original name, but this question is important that can you please suggest any beginner level project to do with high level synthesis? I think it's a very good question. Um, so, uh, so I think you can take many projects. One of the important thing you can do with image processing applications, right? So if you take this image processing application, it can be age detection, blurring, and then increasing the brightness. So many applications are there, right? If you are interested, I can give you a link. Just so that the book has a lot of such image processing applications. So I'll basically give you a paper. So this is one of the course outcome of one of the course project. When I taught this CBS VLSI design here in IIT Guwahati, So this you can do the similar kind of stuff, right? So that can be a very good work. So I'm sharing that link with you. Just give me a second. Let me search it. Yeah. So this is the outcome of one of the course project which was done on image processing application. Okay. So I put it into chat of YouTube. I'm not allowed to post, or okay, I think it's too much of too long text times. Yeah. So this paper you can download. So here what we have shown is like how do you take image processing applications. Maybe I'll open the paper and show you. So you'll get an idea. Let me open the paper and share my screen. Chat here as well. So I'm sharing my screen. I hope my screen is visible. So this was the paper I'm talking about. So this is a course project which I have done here, and one of the student did really well. So I asked him to write the paper. And for this paper, you'll see basically what we have done. We have taken various image processing applications, right? So we have taken this kind of application, right? Graphics processing, morphing and wrapping, then image compression, RAM length encoding, discrete cosine transformation, histogram of equation, image transformation, then noise filter, image segmentation, right? So we have taken these classes of program, and you will get all those things into this 13 to 16 benchmark, 13 to 16. Yeah, so these are the, from here you'll get all these applications, right? Uh, so, but we have taken from this. And then what we have done here is we basically classify, so we identify what are the important thing in image processing. So we identify that a lot of input image, obviously, and then there are a lot of redundancy in the computation, then expression redundancies, then input dependent computations, variable size redundancy. You can go through them. And then we basically talk about that what are the optimization you should do for image processing application so that you can generate better hardware, right, or efficient hardware. So what we have done here, we come up with the idea of like variable optimizations, then instruction translation and migration, right? So iterative redundancies. You can go through this paper. It's a nice paper, right? VRAM optimizations, multi-banking image matrix, right? Pre-synthesis computations, all those things we have done, power on installations. And then we basically say that how this kind of optimization is helping or improving the uh, efficiency of the hardware. And you can see we have actually defined the performance to hardware again. That is a very important thing. What we have shown that if you just increase the latency, right, you reduce the latency, but your area goes very high, then it is very difficult to say, say suppose your latency become half, but area become 10 times, increase by 10 times. That means you are not, your optimization is not good because although you improve your latency by half, so your design will run faster, 2 times faster, but you need 10 times more area. Right, so that's not a good thing. So what you're saying is that this performance to hardware again is that what is the improvement in the speed versus what is the what is the reduction in the speed? Sorry, improvement in the speed by what is the area increment, right? So this ratio should be should be greater than one. If it is greater than one, it's a better transformation, right? So this is how we have defined things. And you can see that for all this design with all my optimization, we are able to increase the speed by 40x, 23x, sometimes 630x also, right? So this is the speed of latency. I mean, basically how fast your design become, and this is the increase in area. So you can see that your speed up is 40x and area increment 36x. So it's still better because you're getting greater than one. But here you can see 13x improvement, but only 1.7x area improvement. So this is a very good thing, 13 by 1.7, right? So this is how we have done things, and so that how each of the cases, what is the tau, right? This tau value should be at least 1. So then your optimization is good. So this can be a good course project for anybody, right? Who want to use HLS, this can be an excellent work. And these are small code. Your HLS C programs are nothing but 39, 40 lines small code. And I think we have GitHub for this, right? Let me check. I think we have done everything and put it into GitHub. Let me see. If it is GitHub, then you can just go to the GitHub, you'll get all the things, right? Let me see. I think it is in GitHub. Let me see. Where is this? I think it is in GitHub. Even if it is not GitHub, you can do the similar thing, right? Uh, but this can be a very good course project for the beginners. I mean, you can take machine learning algorithms, CNN, ANN, and convert them into hardware. You can take post-quantum cryptographic algorithm, AES, DES cryptographic algorithm, but this can be a very good project where you can actually take a set of image processing application and try to come up with some strategy so that you can generate efficient hardware, right? Uh, okay, so this is one thing that I want to mention. Let me see what is the other questions come. Yeah. So this something I hope answer your question. Now, let me check whether it is there in GitHub or not. Give me just a minute. I'll cross check whether if it is there in GitHub, I'll share the link with you so that it will be easy for you. Yeah, it is available. Yeah, so it will be good. I am sharing the link. Okay. So this can be a very good project for you. You can go through it. You can download all the designs that we have there in the paper. You will see everything in this, everything here. Okay. So I think that will be a good resource for you. Okay. So this GitHub link, you will get all the data set for this USB application. Okay, I hope this answers your question, but I think this is very important. If you want to learn carefully, then you need to do some project on your own. Okay. Next question is technology mapping is usually in physical design, sir? But you said the logic synthesis are two optimization and mapping. Yeah, so I think, yes, technology mapping part of logic synthesis. So if you see, you are doing high level synthesis. Your high level synthesis will give you the RTL, and then from RTL you will get the technology map netlist, which is logic synthesis. So it has two parts. First you do the logic optimization, and then you do the technology mapping. In the technology mapping, what you do is basically, if your FPGA target, your netlist or your circuit will be mapped to the LUTs, DSPs, and BRAM. And if it is ASICs target, then it will be mapped to all the technology library gates, right? So you, for say, for example, for ASIC targets and N45 libraries, right? So what will happen? Your design will be mapped or represent in terms of the library gates. So this is what the technology mapping. Physical synthesis start from the technology map netlist, right? In the physical synthesis, what you do? In the physical synthesis, we take this technology map netlist, we do this partitioning, placement, floor planning, then routing, clock tree synthesis, all those things we do, and finally we get the exact layout, right? So this layout will be now taken, uh, and and that will be used for fabrication, right? So you fabricate and you get the physical chip. So that way, I think you are a bit confused, but technology mapping is part of logic synthesis. Uh, So now there is one more question. It said, is this course important for electronic students? Yes, it's a very much important course because nowadays, if you want to develop your hardware, if you try to develop everything from scratch, you try to write your entire Verilog code, uh, it takes a lot of time, right? How about generate this from a C code or a Python code, right? For a think about image processing application that I was talking about, you have this you want to implement. Let's say this you want to do this uh, arithmetic mean filter, right? Noise filters. You want to implement a noise filter in an image. In Verilog level, you probably need 10 days. But if you have this arithmetic noise filter in C, in 2-3 minutes, you'll get a Verilog. So, and then if you know how to use the optimization of the high level synthesis, the way I explained in this paper, you can get your design quickly. So it's basically reduce your overall development time. And I can confidently tell you that uh, many of this, uh, uh, many of this industry people use high level synthesis to generate this hardware accelerated quickly from a specification, right? C++ specification. So it is a good tool for even electronics design. Okay. So Gaurav Sindh asks which tool to use for high-level synthesis. My answer will be VTS or Vivada HLS, so which is a very good tool, right? VTS is the recent version, latest version. Or the older version is Vivado HLS. Both are same thing. And if you are watching my videos, in 8 or 9 weeks, I have added the demo of the tool. The VTs actually I've done for Vivado HLS, but both are same. So it will be good if you go through these videos, the demos, and then you install the tool on your own and try that. I mean, you take some example. I already talked about a few examples. In that way, it will be very good for you, so that whatever theory you've learned in the course, it will become useful. You understand the practical importance, right? So if you learn the theory without doing this, um, without doing things practice or doing some project with the tool, you will not learn the things actually, honestly. When I teach this course in IIT Guwahati, I always give a course project. And course project, 1 year I give on image processing application. In 1 year I give machine learning application. In 1 year I give cryptographic application, right? So every year I give different domain. I give the C program, asks the student to generate the Verilog with this high-level synthesis, apply all the optimization that has been taught in the course, so that people are get familiar with the tool, and then they will appreciate, this is a very good thing, right? I mean, if I have to do this all the Verilog, I'll take month and I'm doing in day, right? So that's the kind of advantage. Okay. So next question, I think from Gaurav. Gaurav I have answered. Gaurav has another question: is there any scope in the industry to study HLS? I mean to say value of the HLS? Yes. I mean, if you are a design engineer in industry, people are using high level synthesis, right? So if you know high level synthesis well, probably you will get more value when you apply for job, right? So, for example, nowadays this LLM is coming, right? People are trying to generate Verilog through LLM, right? A lot of works are done doing nowadays. They are not even doing HLS. They are saying, "Ki, this is my English specification. You give me the Verilog," right? That tool may not be mature yet, but over the time this will become mature and people will keep using this. So similarly, 20 years back, people used to write the entire Verilog on their own. Right now, people are using high-level synthesis because in industry you understand that there is always a time constant. You try to bring your product as soon as possible in the market, right? If your competitor bring your product earlier than you, you lose the market. So that's why for IP development, smaller IP developments, people are using HLS to generate the Verilog QuickTime, right? So it has been quite used. I know at least, I think most of the semiconductor industry design house use high-level synthesis. That I can confidently tell you. And some of the, some of the students in this course may be from industry also. People are using and they want to learn high-level synthesis. So it is useful. Okay, so is there any other questions? I don't see any question, further question. Feel free to ask any question, right? Nothing to worry about. Any kind of question, technical, non-technical, use of the course, anything. So whatever come to your mind, feel free to ask the question, right? I'll be happy to answer. Hi, good evening. So I hope you are listening. So, but please listen the videos, right? Because uh, from NSEM perspective, most of the questions, I will say 50% of the question come directly from the assignments and the course content PPTs. So please watch the videos, uh, take your own note the way you want to learn, right? Everybody has a different style of learning. But make sure that you understand the concepts, right? And try to make good score in the NSEM, which is just in 3 weeks from now. And then I think there are scope for uh, internship, right, through this course. And also, I think you have opportunity to do this pre-doc fellowship, right? There are a lot of scope. NPTEL is now bringing a lot of new things for learner. People are serious about the course. People are doing well in the course. People are coming to IIT through this course performance based on the course performance. Uh, I have already taken intern through my course who have done well, right? In the course, they came to IIT Guwahati for 2 months, did project with me, right? Internship with me. I have taken 2 students so far who have done well in this course, and they come as a pre-doc fellow. Right? Pre-doc fellow is something uh, where he will be in IIT for a year, and it is after your completion of your BTech or BTech or MTech, and it's kind of for 1 year where NPTEL will pay you 25,000 per month. And you can actually learn how to do research and expertise, you experience how to do research. And that might help you to take a decision, oh, I want to go for higher studies, right? So if you're confused about whether I'll go for higher studies or job, this NPTEL pre-doc fellowship is something is a good opportunity where it will give you an option to experience the research way, and probably you may enjoy it. Oh, this is a very great thing. It's exciting. I want to do PhD, right? So, and there is a quite few people who came for pre-doc is now converting into PhD in some other IITs, right? So this way, I think NPTEL is quite, I think giving a lot of opportunity for the good performers in the course. uh, uh, and it's good thing, and it's good for us also, right? We get also get connected with the good students. So this way, I think it's a good opportunity for both of us, for me as well as the students. So I don't see much questions. Any further questions? Um, if I have answered all the questions, then I'm happy, and I want to say thank you. Again, I want to thank all of you to register in my course and doing this course. And this is the last interaction, by the way. Will not any further interaction. Any doubt, you can always put your questions in the course forum where my students, my TAs are answer your questions. And anything you can always reach out to me as well. Okay. Okay. If there is no further questions, in another 2 minutes, I'll close out this session. Let's wait for a couple of minutes to see if any further questions come. Looks like there is no further questions. So, so I'll wait for 2 more minutes and then we'll end off this live session. Again, I'm saying feel free to ask any questions, any options, any career guidance, anything is fine. It's not only to be a question from the course, right? If you're confused about something, no point. There is nothing wrong to ask something here. Okay. Apparently, I think yeah. Thank you, everyone. It's pleasure to be associated with you, all of you, through this course, through this platform. I wish you all the best. I'm sure you'll do well in your course in future in your career. And good luck, everyone. Thank you. So I'll close from now. Okay, so one more question come just before closing down. Nitisa has a question. Find internship opportunity in core companies, sir. How can I find internship opportunities in core companies, sir? I think I don't know, but in IIT Guwahati, a lot of internship tests is being conducted during this during I think March, April that time. Uh, I mean, you have to check with your placements in your college. But in IIT, I have seen nowadays all the companies take tests, right? Online test, and people who have done well, they select for internship, right? Uh, I don't know whether the bigger companies have the bandwidth to take a open test. I think they do it through your college only. At least that is what happening in IIT. In IIT Guwahati, I have seen that most of our BTech students get internship in third year, and it's basically this summer, 3 months in summer, and most of them got PPOs, pre-placement offer through internship. They get their job, right? But the selection process is quite straight. They approach IIT, and their exams happen online, where students give their exam from the lab in the IITs. And then they shortlist and decide, right? So one more questions come from Kurtika. I think there are two questions. Eddie's game. Why don't you use your own name? Some Eddie's game and all those things. How to prepare well for the exam? I think this is an important question. So uh, this time I have given 50% of questions from assignments and the slides, right? Content of the slides. So if you listen the videos and solve all the assignments one more time before coming for the exam, you should score well, right? And other questions are not difficult. The questions are straightforward most of the time. There may be 10% question, little bit of application oriented, little bit, but the way I have said the exam questions, it's mimic the assignments, right? The way I have set in assignments, I'm giving a different example, right? So, for example, I've taken it off. I give to schedule with some MLRC algorithm. I'll give a different graph, and I'll again ask you to do the MLRC algorithm, right? So that way. So, so basically, if you go through the slides very well and re-practice or the practice again the assignments before the exam, that will definitely help. Okay, that is the question. So now Kritika has we so what kind of preparation is needed for VLSI job interview? Um, I think it depends on what kind of job you are looking for. If you are looking for a design engineer position, then you need to have a very strong knowledge about the hardware circuits, language, VSDL, or Verilog, uh, or its tool flows, right? Because when you write a design, you have to synthesize, right? What kind of tool you know, what are the synthesis tool you want, you know, so all those things matter. And I think one important thing is I want to give you this link C2S. So this is a government of India uh, initiative where because this synthesis tools are very very costly and uh, most of the college does not have, right? So this chip to startup is the initiative by government of India through which all the industry level tools are being available to uh, to the college student, right? So your college has to register for that, and so once you register, you can access this tool. I think this is a great initiative by government of India. And if your college is not part of this, I'll strongly suggest you to talk to your professors or your head to register your college into this, and you'll get all the tool access, right? So that's a great thing. Mm, um, and then, so this is, I think, it's very important thing. So, so to answer Krutika's question, you should have a very strong knowledge in the design. uh, I mean, what kind of design, what are the factors, how to optimize the circuits, right? So design perspective on language, Verilog or VSDL, you need to code things in Verilog or VSDL. So design knowledge, language, and the tools to be used to synthesize the design, right? If you just write the Verilog, you need to bring it to the layout level, right? So you need to know what are the tools, how to use them. So all these three factors are important, in my opinion. I think there is one more questions here. Yeah, I think Nitisa again. Are there any NPTEL courses that you recommend to strengthen my VLSI knowledge? Um, so as I um, NPTEL, there are many courses. So I think if you want to are interested in the EDA flow, this course is something in the high level. There is one more course I think by Professor Sneh Saurabh, right? So RTL to GDS, I guess, right? RTL to GDS. Let me search and give you. So this is on the tool side, right? I told you about three things, right? One is basically the design knowledge. Design knowledge, you need to see some VLSI courses that I am not very sure which course is good, but now you need a course that is for the synthesis side, right? So in the synthesis side, my course followed by this Professor Sines of course is quite good. So you can follow that. So I'm giving you this link. Okay, so this you can do. And then for Verilog, you can learn through some courses, right? So for Verilog, there are many courses. One by Professor Indranil Sengupta, then one is from Professor Rafiq from IIT Guwahati. So one language you should know. Verilog may be a good choice. And the EDF flow you should know. So my course plus this SNES Saurabh course is the flow, and one language course. The language course may be, I think Professor Indranil Gupta Sengupta's course is good. I'll just give you that link also. Yeah. So Verilog is the language you should know. So I'm basically, but this will give you some idea. And the design course you have to see. I'm not very sure which course is good. Okay. So some course which will give you the how to make circuit designs and all. This you can cross check. Okay. Okay. I think there is no further questions. Uh, if you have questions, I have no problem to continue further. Uh, just put your questions in the chat. I'll be happy to answer those questions. If I have answered all the questions, then maybe in a couple of minutes I'll wind up. Thank you. Okay, I think I have answered all the questions. Thank you very much for joining this live session. I wish you good luck in the NSM exam as well in your career. Feel free to in touch with me over email or any other thing for other career suggestions. I'll be happy to help you. Okay. Thank you very much. So we can close the session.